Hello, today we are going to take notes over Newton's laws of motion. Last week you learned about the first law of motion. Today we're going to learn about all three, and we're going to touch on that first one again. So Newton's first law of motion is the one that you are most familiar with as of last week. So Newton's first law. This one, we said last week, it's also known as inertia. This one, I consider it kind of like the seatbelt law. It's the whole reason we have seatbelts. You know, when you're driving in the car and the brakes are slammed, you fly forward and that seatbelt keeps you in your seat. That is because of inertia. Because you are an object in motion, and an object in motion will stay at motion. And an object at rest will stay at rest unless acted upon by an outside force. Another example of Newton's first law of motion would be the moon or any of the planets. So here we have my favorite planet, the Earth. And we have our moon, which orbits the Earth. And the moon will continue to orbit the Earth. It will stay in that motion forever and ever and ever unless acted upon by an outside force. Hopefully we never live to see that outside force. The second law seems confusing, but it's really a principle that you've known for all your lives. Newton's second law of motion. You may have heard it before, but you may not have realized what it meant. Newton's second law of motion says that force equals mass times acceleration. Now, when we talk about Newton's second law, we're not going to talk about it in terms of a math problem. But what it's saying is that if you increase the mass, it's going to increase the force necessary to move it. Or if you increase the acceleration or the speed of an object, it's going to increase the force when it makes an impact. Consider a bowling ball versus a tennis ball. A tennis ball is significantly easier to accelerate or to move. It takes a smaller force because it's a smaller mass. This is something you've known as a child. When you want to move a bigger object, you have to put in more force. So, a bigger object requires more force to accelerate it. And again, you can kind of think of it on the flip side. A bigger object is going to have a bigger force if it's accelerating. You'd be much more worried about a bowling ball coming towards you than a tennis ball coming towards you. So we've got our pal here, and he is trying to kick a bowling ball, and it's not quite as easy as kicking a little tennis ball. Bowling ball, tennis ball. Now our next law it's one that you may have heard before but maybe not fully understood. Newton's third law is that for every action there is an equal and opposite reaction. When you are doing a push-up, you push down on the ground, and when you're pushing down, your body lifts up. That opposite and equal reaction. When you're skateboarding, to move forward, you have to push back. So I'm going to have my little pal here on a skateboard. Yay! And he pushes backward to go forward. It's important to remember that with Newton's third law, it's always at the exact same moment. If you've ever played pool or billiards, that's a great example of equal and opposite reaction. Newton's cradle, which I've got right here, you pull one back and it sends one out. If you pull two, it will always push out the same number that you pull. It's equal and it's opposite. It's not cause and effect, it's at the exact same time. Let me know if you have any questions about these laws. Thanks.